So a lot of what I'm going to talk about today, there is quite actually some overlap with what James was saying, so it does naturally lead into it, which is quite useful because I can skip over a few bits. So as it says, serverless event-driven AI as a service. That's not just me putting loads of keywords in to try and get you all here. I will be touching on all of them. So I'm Martyn Kilbryde, so I'm Principal Architect at D55. So we're a consultancy here in Manchester. And yeah, for a day-to-day basis, we work with serverless, we work with AWS, cloud native, full-time. Thank you. Okay, so yeah, so I'm going to go on a journey through this piece of work that I've developed. I'll actually show the end product right at the end. I'll show the full diagram, but I'm just going to go on this kind of journey. So the whole thing's going to be serverless, be cloud native. The whole thing's written in CDK, and it's going to be event-driven. So we're going to have separate components, and each of them sort of microservices will be something that could be in a separate repo, a separate team, and it's all going to be communication via events. And as we go through that, there's going to be a lot of cloud native patterns or serverless patterns. So I'm going to try and touch on analytics and alerting and just different ways you can do things. The hope, by touching lots of little things, you'll get some ideas of things that you could possibly do yourself. And I'm going to use a Twitter bot for this. The main reason I've decided to do a Twitter bot is I didn't want to do anything domain, like specific, something that would be complicated by the business nature, but also it needs to be reactive. It needs to be driven by events. So the only thing really that you need to know about this is that Twitter has something called the Account Activity API. And for that, effectively, you get a webhook through into our system every time something happens on my account. So if you send a tweet to me or I delete a tweet, that kind of thing, then it will yeah, it'll send an alert to my API, and then we can react off the back of that. So I touched on just a second ago is the whole thing is just one CDK application that includes the infrastructure code, that includes Lambda as well. And yeah, it's open source, so at the end I'll share a QR code, so feel free to download it, and maybe there'll be some useful things in there. So the first microservice I'm going to start with is just getting the data in. The only thing really, the connectivity you need to know is we get a post and a get. The get is for authentication, the post is the actual details. So if you want to do that serverless in AWS, then API gateway is obviously where you'd go. Completely managed, you don't have to do anything to manage it apart from set up your endpoints. You can configure how many requests, if there's limits in there, etc. So we'll get them requests into API gateway. Now at this point we could say push into EventBridge direct or into SQS or into a step function like James touched on. But the authentication mechanism for Twitter is that they need to do some, you have like a private secret and you need to do some sort of hash. So in this scenario what we've got is we've got this hash, these API details stored in Secrets Manager. And that's just, again, don't have to manage it as a managed service, but that will just keep hold of them encrypted. And that's outside of the repo. So if you are going to run this, you need to set the secrets up manually, put your details in there, and then the whole thing will just pull them and use them. Now in API Gateway, the way you would usually do authentication is, if you need to do something custom like that, is you can use a Lambda authorizer. So it would execute a Lambda and let Lambda do its authentication, its authorization, and then go on to your integration wherever that's going to be. So because we need to do that and we want to have some sort of basic anti-corruption layer, which I'll touch on in a sec, it makes sense to actually use something called proxy integration on API Gateway. So that'll literally just kind of proxy through the request straight to Lambda and let the Lambda do authentication and output any events that need to be output. And what I've just shown you there is effectively defined in just this set of code. So in CDK, It's a little bit chopped down, but at the top you can see where we're just retrieving the secret. So this is just getting a reference to the secret in Secrets Manager so we can use it in the Lambda. The second part of this is we've created a custom construct called the Twitter construct, and that's just holding the IAM roles and the actual Lambda itself. So in this case, all you really need to know for this bit of code is construct.lambda will be the Lambda that gets created. Really the big part is at the bottom. So with just the kind of lines of code, which, .lambda REST API, that will create a full API gateway REST API backed by a Lambda. So in the case of like a proxy. So you don't need to define more than that if you want just a full proxy integration. What I've actually done here is define proxies faults. And that's because I wanted to define the actual resources and methods at the bottom. Now, typically, if you're doing a full Lambda proxy, you probably wouldn't do that because you might want to have, say, Express running in Lambda. Or if you're doing .NET, you can have a full, effectively, web server in there. The benefit of doing it this way, and it's just, again, just a bit of a pattern I wanted added so people know it exists, is it means API Gate will enforce that the only requests hitting that Lambda are on the Twitter, like the /Twitter endpoint, are gets and posts, so it just cuts down on a bit of noise. The other benefit is if you start having different endpoints for different things, you could sort of limit it that way. Now, the events that come out of that Ingress Microservice, as I'm calling it, like I say, it's a self-contained CDK stack that could be managed by its own team, is we're going to go into effectively the hub of the whole application, calling the plumbing microservice because that's effectively what it's there to do. And really all this needs to contain is an event bus in EventBridge. Now, EventBridge, I'm not going to go into it too much because obviously James has just gone through that for me, which is very useful. But all I need to know is we've got a custom event bus and created with one line of code. And now anyone can send events to that, and as long as it adheres to the EventBridge JSON structure, it'll get shipped through, and then obviously we can add kind of rules to that to start pulling specific events off. So we put that in place, and then this plumbing microservice is now effectively shipping an event bus endpoint to all the other microservices for them to use, and each of their microservices will be in control of their rules. So this team, for example, just supplies the infrastructure. Now, a couple of things I've got at the bottom that I find quite useful on the right-hand side is having a rule in there which gets every single event that goes through and pulling it into CloudWatch. So you've got a log of every single event. There's been times where we've gotten a bus and you just don't know what's flowing through it. So this way is quite good for debugging, but also for metric filters, which I'll touch on in a second. The other thing is that I've turned on the event archive on the left. Now this is just something that you enable in on the event bus itself, and all it'll do is it'll store all of the events in that archive for a certain amount of time, just for replayability. So you'll end up with an archive set up something like this, where you might be able to see we've got 7-day retention and it's currently got a few hundred events. Now, that archive, you cannot view that archive, you can't go into it and see what events are in there necessarily, which is why having the CloudWatch is quite useful because you can see the specifics. The biggest thing with having this is this replay button. So if you click that, you can then specifically choose a time frame for replaying your events. And all it'll do is you give it a specific time frame from and to, and it'll start in the first minute, and it'll ship all the events that were sent to the event bus in that minute back through the event bus. So any new rules, any new services, any services that were down during that time that are now back up will start receiving these events again. And this is why one of the big things with EventBridge and just event sort of architecture in general is you will get events potentially out of order. So not just the fact you've replayed it and it's come back in a week later, but also just in general, there's no guarantee of the order. And you can get events multiple times. So you need to take that into account of anyone who's using this to try and make sure you don't process things twice. Now, going back onto where we're logging the events, so one of the things that's quite useful is metric filters in CloudWatch, which when I discovered this, there's quite a lot of use cases in the past that I thought this could apply to, so I think it's quite a useful pattern. So bear in mind, all we're doing is sending JSON into CloudWatch, and it's just logging it all. By putting a metric filter in place, we can just define a filter pattern, and that can just be a piece of text. It's case sensitive, so it could just be error, something along them lines, and every time that is seen when it's being logged, you can then use a metric, and you've got metric value at the bottom, so you can pull metrics out. So say you're logging how long it took to hit a database, or in this case, every time we see a message with detail type message analyzed, we've got a metric value of 1 because we've received 1. And these can be added in CDK quite simply. So using this function at the bottom, we're just going to create a metric filter for any type of detail type, which is a specific field that you have in EventBridge, in the events through event buses, and we'll get metrics. And then suddenly we can start to use a lot of the graphing functionality that you get to just start graphing them out. You can have alerts on there and so on. So in this application, there's an example where you could go in and just see, because it's every single piece of activity on my Twitter account. If I send tweets, if I favorite, etc., I've got all them stats in there if I really wanted to. Now, just to look at one of the example of the events. So this here event on the left, this is effectively when we get the event in from Twitter, what it actually looks like is what's in the detail section. So we get a load of JSON. The schema for that JSON is defined by Twitter. So all we've done in this case, we've created an event to push into EventBridge, and we've set at the top the detail type and source. Now source, these are things that you have to set when you send an event. So source Twitter, because obviously that's where it's come from. Detail type is effectively a description of what is going to be in the detail field. So in this case, what we're actually doing is just putting like Twitter underscore and then taking the type of request we got from Twitter and just dumping it into detail. So this kind of can just be shipped into the event bus, and it might be that nothing listens to it. It'll get logged. But what it does mean is that anyone can start to pull bits of information from this if they really want to. But the one thing to be careful of is now the whole of application would now be sort of have to adhere to the schema that Twitter is sending to us. So that's why I mentioned like a bit of an anti-corruption layer where we also send a specific event for this application. So this is something we've defined internally. We have to follow all the rules you would with events, which is backwards compatibility and so on. So that event on the right is kind of a cut down version of the event on the left that we will use to drive the application, rather than telling everyone in the business, you need to deal with this, and then Twitter changes something and things, start to break. So the only really important bit you need to know for the actual application that I'm showing is just that we're passing the text and any images that I receive through, and a few details about the actual tweet. Now the first use case for this is we're going to do analysis on it. And going back to the AI as a service, this is where more of the overlap with what James was saying actually is, because we're going to use Comprehend for some of the sentiment analysis as well, also Rekognition there for the images. So I'll jump into the workflow in one sec. But just as an example of this is analysis, it's a stack, it's a completely separate service again. This deploys a rule into onto the event bus, and it just says every time there's a message received detail type, execute this step function. The step function is going to, it's going to do analysis on the text. We could have multiple images or no images, so it's got to do some analysis on them images, and then we're going to output an event. Now, step functions are really useful for this scenario, especially because what we've effectively got here is an orchestration problem. because what we need to do is we need to call multiple APIs on multiple services, and all of that will make up a single piece of analysis. If we just received the event and went straight into, let's say, comprehend, we'll end up with all these events coming out where we have to stitch them back together. And just to show it from a workflow point of view, this is just a direct export straight from step functions, so it should be quite familiar if you've ever seen the diagrams. But the beauty of step functions is you can understand that without understanding step functions. And also you can sit and work with business people and they can understand it as well, which is quite useful. So just working down very quickly, in parallel we're going to detect entities and sentiment on the text, which I'll touch on in a sec, a little bit more detail. And on the right, if there is an image, then we're going to have to download them images. So we do have a lambda here, sorry. So we're going to download these, there could be multiple images, and they need to be either in S3 or you need the bytes from the image effectively to call Rekognition. So that lambda download images to S3 literally would just loop through them URLs, download into S3 and return the keys of where they exist. And then in parallel at the bottom, for each of the images, so we've got a map, and that map is like effectively a parallel for each, is going to detect labels, text, and celebrities, and actually just faces in general using that endpoint. So there's 5 separate API calls that it's going to make as a minimum if we get an image and text. I am just kind of throwing services at this to do a full analysis. Obviously, it's probably better to target it to specific use cases if you were doing something similar. And then right at the bottom, when we've got all of the, say there's 10 images and there's a piece of text, we've got all of that analysis comes out and we push it all under push result as an event back into event bus as a message analyzed. If anything fails, there's a try catch, push fail results. We push an event saying something failed that we can then use later on. So starting looking at some of the AI we're using, so comprehend, obviously you've seen a bit of this, and a slightly better example of where you might actually use some of this is like reviews. So you've got the sentiment analysis. There's quite a lot in comprehend. It's probably more useful when you've got large pieces of text like documents or reviews. Obviously with tweets, you're not going to get as much from it as you probably will, but again, it's a kind of decent demonstration. So like custom classification, and topic modeling are both very similar sort of things where you can work out what kind of thing the text's talking about or segregate it off into different topics. The personal identification kind of data redaction and stuff like that is obviously quite useful depending on what you're doing as well. We're actually going to use entity recognition, which just looks for specific entities like brands, names, and so on, and sentiment analysis. Targeted sentiment is specifically sentiment analysis about a specific entity, so you can see if people are saying positive things about a certain thing. And then we're just doing that directly with no lambda calls, so this probably look very similar to what you've just seen, but this is in TypeScript. So we're just calling Egress service and passing in the text. In this scenario, I am just hard coding it to English because I'm assuming people texting me, sending me tweets are English, but we could use detect language above it and go from there. So both of them are the steps in that step function itself. Now for Rekognition, a little bit more interesting when it comes to AI. So it does images and video, and with the different things there you can go down. So let's say object and scene detection. And the example of that I've used myself is with my cameras at home, send sort of, you get an alert saying there's been motion, send it to Rekognition and it'll tell you that there's a dog or a cat or something in your garden rather than a person. So it can be quite useful depending on use case. You've got different types of facial recognition, analysis and comparison in there. So you can have a database of faces and work out who it is, or celebrities being just a public database of faces. It also will tell you what kind of, if they're smiling, if they're sad, that kind of thing. Text and image, a little bit of an OCR. It's not, there is a separate service for doing full document kind of textract, it's called. But this will give you if there's a specific piece of text in that image. PPE detection. There's probably a specific use case there somebody can think of for making sure people are wearing PPE. And unsafe image detection, they also have that linked up with their augmented AI, I think it's called. So it can go to a human for like double checking. You can understand what sort of thing you might use that for. And the integration for that is very similar. So I've just shown one example here, but we're just passing the bucket and the key, so the location of where that image is, and sending it off, in this case, to detect labels. And that'll give us back a list, which I'll show in a second example of. So this is very cut down because you get a lot of data. So it's probably not perfect JSON now that I've shoved it up together, but it shows you the different data that we would get from, say, a tweet of a picture. So we've got text sentiment at the top, so a bit of text in that tweet as well. It's just neutral in this case. Recognize the celebrity, so we've got an array of the faces it's recognized, and you can see we've got the boxes where the heads were, along with landmarks, so where their eyes are and so on, and pose. You do have emotions as well, so you can see 59% definitely sad, and quality in there as well, and not smiling, which does go well with the sad, and who this person is, which you might be able to guess the image based on just that alone. Unrecognized faces in this scenario, because we're hitting the recognized celebrities endpoint, is a kind of similar sort of list, but without names. So it's very similar to just hitting the facial analysis kind of endpoint. Labels, it's very cut down in this case because I couldn't show it all on one slide, but this is the object detection. So you do get this hierarchy of parents and the actual object. So you'll get something, say shoe, and it'll say the parents of that is footwear and clothing. So you'll also get an object of clothing. So back to the kind of, if you're doing detection on CCTV, you might have something where you look for person. You're not necessarily going to want to look for man, woman, and child or something. So it gives you that hierarchy depending on what you want to match on. Text detections, I think, is quite self-explanatory. That's just what it's seen in the image, along with where it was. And then right at the bottom, you've got text entities. So this is the bit where we've, based on the tweet that I actually received, it's done some analysis on, and it goes, this is the person, this is something else. And so it gives you these different types of entities that is recognized in the text. So here we've got an incredibly simple use case, which I think is just a decent demonstration of the targeting that you can do inside EventBridge's rules. So now we've got an output of message analyzed coming out of that step function. And in there, as you saw there, we've got text sentiment at the top of neutral. So we can write a rule which just looks for text sentiment negative, for example. And in that scenario, it'll match, and you target, in this case, I've got an SNS topic where we can subscribe emails to, or you could put an integration into Slack or whatever. And the setup for that is, as simple as what you can see there. So we've created the rule at the top. You've got the pattern that you want to match on. So we've got detail type specifically message analyzed, and that's an array because you can match on multiple things if you want. And then detail in EventBridge is just like an any field. It can store any JSON. So we're actually saying, because we know what the schema is, that under analysis, under text sentiment of negative. So that particular rule will suddenly start matching. The target for that is set at the bottom. So we're just creating a new topic, and the event will get passed to that. And the message bit I've got at the bottom is just a good example of effectively being able to, rather than just send the full JSON through to SNS, we can actually do a little bit of transformation on that, pick out the bit of text and write a message. So if somebody sends me a tweet right now saying what you're saying is shit, then it'll come through, I'll get an email on my phone and it'll tell me what. So yeah, it's just an example of, obviously in this case, you probably would want to actually send it to a queue or something where you can actually manage it better. But then we've got what I find quite a good benefit of having just this single bus is the ability to have analytics without building it into the different services. So remember, each one of these is a completely separate service. So for this one, all I've got at the top left, you can see all events. So this is just a catch-all rule in EventBridge. So every event, from the raw request we get from Twitter to the message received, message analyzed, etc., all get fired in. And what we're doing here is targeting on that rule, Kinesis data fire hose. So going back to the topic of the talk, that is serverless. There is very little setup you need to do in there. It will manage it for you. So the only thing really that's configured in there is a kind of buffer, which you can see the code at the bottom, for setting up a buffer of 60 seconds. So all the events will flow into there. Kinesis will wait 60 seconds or until it hits, I think it's a megabyte, or it hits a certain limit, and then it'll dump it wherever you want. So in this case, we're using data firehose to stream it into a S3 bucket, which will act as a data lake. It can go into a data warehouse as well, or into OpenSearch, for example. So if you just need to ship data into this managed way, it's a really good tool to look at. Now, one of the things that you can do with data firehose is transform that data. Now, you can just do it directly in data firehose, so you can sort of convert the format into something that's easier to query, because JSON isn't the best for querying. But if you want to do that, you probably need to define your metadata. So if you don't know the type of events, so in this case, we're just throwing all the events through there, then actually what I'm doing here is I've got a transformer which just puts a new line on the end of every single message that we get. Otherwise, it will just create a file where everything is in one long sort of line, and that's quite hard for querying. And again, it's just to show a pattern of what you can do in terms of transformation. That Lambda, you can look at the code later, but would just receive a list of these messages. You can do some transformation and return it back out. Now, once it's in a data lake, again, data lake is just as a definition, is just kind of unstructured data in a way. You've just thrown the data in there. It's not like a data warehouse. But if you do want to do sort of any kind of ad hoc queries on there, this is where Athena comes in. Athena, again, going back to the topic, serverless, so you don't have to manage anything there. You just get paid for the amount of data it scans. So if you've got a huge data lake and you do a select all, it will cost more than doing targeted specific queries. And if you're doing this a lot, you would want to convert the format from JSON or consider going into like a data warehouse. Now, for Athena to be able to query that data, and it does query the data directly, you do need some sort of metadata, and that's where Glue comes in. Now, Glue, again, as a serverless service, but you don't need to do much configuration. There's a few different methods you can use in this scenario. So you can set it to crawl the bucket every so often, and it'll discover the schemas and sort of auto-create these kind of tables. Or you can specifically set up them tables ahead of time, so you can define them in CDK and deploy them. And then based on just having a table definition, which shows what the data kind of looks like and all that data, you can then run some queries directly against a load of text files. And just some simple examples there where we've got these deep pieces of JSON, so we're just looking for all of them and then kind of cross-joining them up to get just the list of celebrities. Or on the right, we're actually doing counts and orders and so on. Very useful if you're just doing these ad hoc things. I've seen use cases where you might have SQS queues where you're sending them all into S3, so you can query the type of data that's going through there. And then maybe based on that analysis, you can then go, okay, we need a specific data warehouse. Now on to the final use case of an AI service. We've got the actual trying to build a response. Now, as we've got this message analyzed thing which is flying through the event bus, that's got on there. If it had an image, it's got some sort of image analysis on there. If it had text, we've got your text analysis. Now, the scenario I've done for this is that if you send me an image, it will just take the first image you send me and do something with it. If you send me text, then it will run it through Lex and try and do a basic conversation with it. So what we actually got is two use cases here. So responding is its own separate microservice, but we've got two rules which come into it. So we're matching on whether the media array is kind of empty or not. So I'll start at the bottom because it's a little bit simpler. If it does have images in there, then all we actually need to do in this scenario is we're going to write over the top of the image the name of the celebrity that's been discovered, and send a tweet back out to the person in a reply which says we discovered this person and the image that's been modified. So we've got a lambda at the bottom there which will pull the image from S3, quickly write the text over the top, and then generate a send tweet command which will go back through event bus to say please send a tweet to this person with this text and with this image. For the text at the top, I've dipped my toes slightly into Lex. Lex is quite complicated, there's a lot to it, so but this has got a use case in there which I'll go on to the next slide. I'll tell you a little bit more about it. All you really need to know as well is Lex can use Lambda for fulfillment of specific data, which is why I've got that at the top. So for Amazon Lex, if you've not heard of it, the way it's defined is it's the same technology as Alexa, but it's a little bit disappointing because it's quite empty, that you have to configure it up to be your use case. I hoped I could just shove it on there and I'd get Alexa, but I'd have to actually go down the Alexa route for that. So their use cases they show on the website, like ordering pizzas and things like that, is kind of where it comes into its own. So you configure it up to say these different, when somebody messages me they want to order a pizza, it'll go through the conversation to get all the details, where they live, what type of toppings and so on. And it'll then send the order into, say, Lambda, where we can actually place the order. You can also train it up from existing logs if you've got a load of conversational logs, which might save some time. I've not tried that, so I couldn't say too much about it. And it is voice and text. So it's been trained on telephony voices, so not just crystal clear voices. And it can integrate directly with Poly, which is what they use for doing text-to-speech. So you can have a full kind of back-and-forth conversation on a phone using this. And that includes the context management. Like I say, if you're ordering a pizza, there's a lot of back and forth. There's a kind of session. It's like the live chat scenario. And there's integrations with Amazon Connect for that specific use case, which is the Amazon kind of call center offering. It does integrate into Kendra as well, which is their intelligent search. So it's give it the full Wikipedia of all your internal information, and it'll intelligently look for that piece of information that somebody might have asked. And Lambda is one of the use cases. So one of the ways you configure that is you give it what they call intents. So I've configured an intent called joke. And what you need to do is give it some sample, what they call utterances, so things people might say to mean that's the intent that person has got. And then it'll use that, and it's already existing trained to try and match on these intents. So you can have many of these. So I've got 2 in this application. And if it can't find an intent, you've got like a fallback intent, which can be like, sorry, I don't understand, I can do this kind of thing. Then based on if it does match an intent, you can then have things called slots, which is like piece of information it needs to get to fulfill the intent. So that could be like, it could be an order pizza intent, and then to do that you need to know the size of the pizza and so on. For this scenario, I want a joke. There are no slots in there. We just need to find a joke for you. And at the bottom we've just got it enabled true on that kind of code hook. So for fulfillment it's going to call into Lambda. So this shows just how to call Lex. So, really simple. That's all I really wanted to demonstrate is once it's set up, you just do an API call. And this could be in a step function, but the reason it can't be in a step function is just because of some of the other processing that's in there. So just an API call. I'm just passing a session ID, which is got to be unique for that specific conversation. I'm just sending author, which is actually your Twitter handle. And text, which is the actual piece of text that came through. Then if Lex will build a response and return their piece of message, like a message we need to send back to the person. If it's figured out the intent, it'll call the Lambda that I've set up. So in this case, if the intent was fact, we're going to get a fact. If the intent wasn't that, I've only got 2 intents, so I'm getting a joke. And we just say that's fulfilled. We could return many other responses. Like I say, I'm only touching the surface of Lex, but I think it's just an introduction to what you can do with it. And then finally, just to touch on how we get back out. There's not too much to say about this one because it's probably what you expect. So we've got a send tweet command that'll fly in from our event bus. We need to basically build up some API calls. Now we could potentially use direct from EventBridge API destinations where you can just call an API, do transformation, and you don't need any code. But in this scenario, we actually need to pull the image from S3, upload that, get an ID back, and then create a tweet. So it's quite complicated. Therefore, it needs a Lambda to do that in this scenario. And again, it needs to pull the API secrets from making that call from Secrets Manager, but ultimately it just creates that tweet. And obviously, you probably can't see too much, but that's the full application that I've gone through. Obviously, I know it's quite overcomplicated for just a Twitter bot, that Twitter bot that doesn't actually do a huge amount. It's got 3 use cases, but it's just an example again of showing, hopefully, many different patterns for how you can, you can add some of these into your application. And on the left is my Twitter handle. If anyone wants to now send me a tweet, they can. I will disable it at some point so you can talk to me and not a bot. But yeah, if you send an image, it will try and recognize a celebrity. So we have tried that with a few different things, like taking a picture of a TV screen, seeing if it can recognize the person. Middle one, get hold of the code. So if you want to pull this CDK TypeScript down, feel free. And yeah, D55 at the end. If you want to speak to us about any sort of consulting, or you just want to get in touch to check it, talk about some more of this stuff, feel free. Otherwise, that's it. Thank you. Okay, has anyone got any questions? No? It's good for me.
Awesome, cool. So I think, is there one there? One question?
Oh yeah, we've got one. Thank you.
Yeah. Just maybe a detail question. Do you know the recognition for video recognition? Does it recognize activities that happens in the video, or is it just objects? Sorry.
Yes. I'm trying to think of a specific example of an activity. I'm sure I have seen, I might be wrong, I'm seeing, so I said with the camera example, the reason we had that is we've got chickens in the garden, so we have the camera pointing at the garden, and if we see a fox, we want an alert. But we also, it catches the road, and you definitely get alerts for cars, vehicles, and so on. I can't remember if drive, for example, or move was in there. So, yeah, I'd have to double check.